Okay. Good evening. Can you hear me? Sorry, I was late today. 15 minutes, right? Okay. No issue. Last week, actually not last week, uh, before last week, we discussed about basic parts of industrial chemistry. What's the meaning of chemical industry, and what are the factors need to be considered when we starting and maintaining? What are the main requirements? Do you remember we discussed 5 main requirements to start and maintain chemical industry? We discussed 5 main requirements. What are they? That we called as 5M concept, right? That we called as 5M concept. 5M concept. 5M concept. Okay, what are the 5M concept? Do you remember? What's the first one? Money. Very good. Second one. First M for money. Second M, good manpower. Third M, machines. Machines. Fourth M, material. And methods. Fifth M is method. Okay, they are the 5M concept. If you need to start or maintain a chemical industry, start and continue chemical industry, they are the main requirement. To start and maintain money required, the most important factor is the manpower, because all resources managed together by use human resources, right? Human resources. And machines, we can increase the efficiency of the production process. Materials, when we select materials, what are the factors need to be considered? Every time they are asking, what are the factors need to be considered when we select material? Wide availability, the accessibility, that means the transportation ability. What else? The purity, the quality of the raw material. And what else? The wide availability. Okay, they are the main factor. This point is very, very important. And I have paused your tunes. Still you don't have. Okay, not Sunday, Friday or Saturday you can collect your tune. Okay, methods. How you can select most suitable method for chemical industry? Okay, we can have more than one method, more than one suitable methods. Okay, analyzing these all methods, we have to select most suitable method to use your chemical industry. Most suitable method. You have to analyze your environment factors, raw material quality factors, and your production process, production factory, your facilities. According to your facilities, surrounding, and your requirement, actually, raw material qualities, you can decide which method is more suitable for your chemical industry. Okay, more than one in the world, more than one method. Sometimes five to six method per one chemical process. But you have to select more suitable method, use analyzing. I told 5S concept. Say Seiton, say get to like 5S concept we can use to find most suitable method among more than one methods. Okay, Matakane? Remember, right? That's from last week lesson. Okay, that we already discussed. Okay, these factors very important. Wide availability when we select raw materials, wide availability and easy accessibility, that means transportation ability and the purity of raw material, very important, these factors. Okay, they are the different chemical industries that we discussed. Hari. And the MSDS sheet we already discussed. I told research 5S concept. Yeah, I can remember. Yes. Did you research? Pagatal? Good. Others? Dihini? Okay, what are the Seiketsu? What? What else? 5S. Yeah. Sort, set in order, shine, standardize, sustain. Safety is a new one. It's a modified version. Okay, they are the sort, set in order, shine, standardize, and sustain. Yes, they are the 5S concept in English. These words are Japan words. Japan word. Okay, according to these factors, analyzing according to sorting and order and find most shine idea, they are the options, they are the methods. We can select more suitable methods among more than one methods, possible methods. Hari. Okay, we discussed about MSDS and finally we discussed about chemical reaction chamber. No, chemical reaction chamber. Yes, parts of chemical reaction chamber that we called as tire and heating pan. They are reactant input valve, pipe, byproduct output valve and pipe, and this is a cooling system and motor. Okay, that's a common structure of the chemical reaction chamber. Chemical reaction chamber. What's the meaning of reaction chamber? Always in chemical industry take place chemical reactions. This chemical reaction take place in a container. That container we called as a reaction chamber, chemical reaction chamber. Right? I think you can remember. Okay. We discussed up to this point, right? Am I correct? Safety and environment consideration. Up to this point we discussed, right? Dihini? Kabir? quickly. Yeah, safety and environment consideration. That means the chemical reaction chamber completed. Okay, now we are moving to production process, chemical production process. Under this chemical production process, as I told last week, we have 5 main chemical industries. We have 5 main chemical industries. Today we are going to start our first chemical industry. It is soap production, and this is the most very important session, because you can go through past papers frequently asked in the soap production. Soap production, actually, if you read whatever note and understand it, little bit difficult, because it has lot of theory component. Theory godak theory. But within today's session, I will explain step by steps what we doing in with chemical changes and chemical conversions. I will show you step by step what happening soap production. Actually, if you got the imagination like a picture, if you have idea like a picture, initial to final stage, you can answer for any question. You should have a picture. That means step by step methods of soap production. That enough. And the step by step changes, chemical changes and physical changes and adding materials like this. Okay, I'll explain one by one, step by step. Please try to get a short note. You can note down a short note. Then you can easily understand. In this lesson, as I told last week, we have 5 main chemical industries. What are the chemical industries? The first one is soap production. Soap production. Soap production. I think you can remember last week I told you in Sri Lanka, chemical industries, chemical production industries are very rare, very limited number of, sometimes 2 to 3 times of chemical industries in Sri Lanka. The chemical industry actually very poor, very rare in Sri Lanka. That's why as technology students and chemistry students also learning this lesson, especially for chemistry, technology students learn this lesson. Please try it. Last week I already explained the current situation of the country. In Sri Lanka, very rare chemical industries, paper production. Now you know, if it is due to something pandemic or whatever, pandemic or economic crisis, if we can't import, in Sri Lanka don't have our own paper production. Paper also more than 6 to 7% import to Sri Lanka. Fertilizer and 100% acid import. No any production in chemical. Actually, if you got overall chemical productions, 1 to 2% producing in Sri Lanka. More than 98, 97 import to Sri Lanka. That's why whatever pandemic or economic crisis, we have a lot of issues. The first one, energy. Energy, okay, we have to import, but others, chemicals we can produce in Sri Lanka. Some up to some level we can produce, but still we very poor level chemical industries. As technology student, you are learning. Please try to understand please try to find out current situations in the Sri Lanka related chemical industries. And as technologies, the government, the purpose, learning as technologies, you're learning this lesson, find solution for these questions, these problems. Okay, in this lesson, we're discussing 5 main chemical industries. The first one, soap production. Soap production. Soap production. The second one, biodiesel production. Biodiesel is another now very, very important. I think this time 2026 biodiesel question is compulsory coming in essay part, because nowadays the most challenging thing is energy. Not only Sri Lanka, entire world, right? Entire world now facing for energy crisis. Energy crisis. Therefore, entire world more tends to renewable energy source. More focus nowadays, more focus into renewable energy source. Okay, biodiesel is a type of renewable energy source. Therefore, this time 2026 most possible to ask biodiesel question. Third one, panic production. Fourth one, fertilizer production. In this lesson, we mainly discussed about phosphate fertilizer production. Phosphate fertilizer production, because do you know we have a huge drone, apatite drone. Apatite is a raw material for produce phosphate fertilizer. Apatite, we have apatite, very large scale apatite drone in Eppaval. Close to Udawalawa, Eppavala කියන area එකේ තියෙනවා apatite drone එකක්. You can search about them. Lot of and tutorials are there. It's more valuable, but in Sri Lanka still we don't have apatite phosphate fertilizer production industry. They are the problems. That's why we are importing phosphate fertilizer. Okay, fifth, final one, paper production. Paper production. Paper production. Actually, these all industries, soap, biodiesel, paint, phosphate fertilizer, paper, all industries, we have resources. For paper production, we have resources. We have machines, and we have lot of plants. You know, paper production main raw material finest plants and eucalyptus and finest. We have a lot of uncultivating free areas. We can cultivate finest, and we can motivate paper production. But still, our paper production is very low, more than 50% import to Sri Lanka, import from other countries. Okay, Hari. Okay, that's a summary of the lesson. Okay, let's start the first production process, soap production. Okay, have any idea what's the purpose of producing soap? What's the purpose of producing soap? Soap is important to maintain the healthy, actually. Maintain the health of humans. Health of humans. That means, think you have your whatever plate or whatever your instrument. Apply strain particle, lipid particle. If you wash by water many times, can you remove this? Can you remove this oil stain? No. You have to apply soap. Without applying soap, you can't remove this oil stain. Okay, actually, the lot of dirt particles, that means non-polar dirt particles, non-polar dust particles, not dissolve in water, not dissolve in water, but lot of more than 90%, 99% impurities, dust particles dissolve in water. Dissolve in soaps. If a soap will dissolve වුණාට පස්සේ soap is water soluble. Therefore, we can remove soap by water. I will show you, I will explain the washing process of the washing mechanism of soap. Okay, now just understand the soap is very important to maintain the healthy of lifestyle. Different types of soaps are used in different purposes. Yes. Yes, different types of soaps using different purposes. Different types of soaps. Sometimes soap powders, shampoo, and different face wash types. No, they all are soap. What is that we bathing bars container, long bathing bars for washing process, washing purpose. ඒව ගන්න මේ washing වලට වෙද්දී එහෙම clothes. Okay, and we have soft soap types, baby soaps, and different medium life boy, different names, different types of soaps, right? For example, soaps used in for cleaning the bodies of adults and different from those used baby soaps are made and gentle smooth skins. Okay, different purposes, different soap types are available. Okay, now we are going to discuss how to produce these different soap types, different soap types for different purposes. However, if it is different soap type, the chemical reaction and the basic raw materials all are only final stage, the filling material and coloring agent, and that's how they are changed the purpose and shape and their texture. Everything depends on the final stage. But the soap production process for any type of soap, it is same structure, same steps, same raw material, same product is produced. Finally the adult that we call as a what we call the filling materials, the final stage only, the designing process is a different final stage. That's how different types of soaps producing by adding different types of filling materials, different smell agent, different coloring agents, and we can make it with different textures by changing filling agents. Okay, I will explain everything step by steps very carefully. Okay, now do you know what are the main raw materials for soap production? Soap production, what are the main raw materials? මොනවද අපි ගන්න raw materials? Do you have any idea? Do you have any idea? What are the main raw materials? Tini, what are the main raw materials? Anyone? Khabir? Udanne? What are the main raw materials required to produce soaps? Prehlan, what are the main raw materials? No idea. The main raw materials are animal or plant, whatever oil that we called as triglyceride. Triglyceride, you already know, right? Triglyceride is the main raw material. Triglyceride, fats or oil, animal fat or vegetable oil, animal oil or vegetable oil, we can use as triglyceride, that we call as triglyceride. Triglyceride, you already know how to produce triglyceride. Triglyceride. How to make triglyceride? What are the building blocks of triglyceride? I need the answer quickly. What are the building blocks of triglyceride? In biomolecule lesson we discussed. Quickly. The building blocks of triglyceride. Sarmia, Tania. Building blocks of triglyceride. How to form a triglyceride? Triglyceride means fat or lipid. That means if it is room temperature, solid, if it is room temperature, solid state lipid, that we call as fat. At room temperature, liquid state fats, liquid state lipids we called as oil, right? I think you can remember. Now, how to form triglyceride? Dini, quickly. How to form a triglyceride? Very good. Triglyceride is formed by 3 fatty acids and 1 glycerol. 1 glycerol connect with 3 fatty acids. Now you can't forget biomolecule, because next lesson, for our next lesson, the next lesson is the natural products. For natural products, for natural products, no, Rehla, it is glycerol. Rehlan, this is the glycerol. Glycerol connect with 3 fatty acid, that we call as triglyceride. Yeah, previously I told you, for natural product lesson you need complete biomolecule knowledge. Without that you can't understand. Therefore, if you miss any part of biomolecule, please go through and complete biomolecule first before you start natural product. Right. Now, what are the main raw materials for soap production? Whatever triglyceride, that can be animal or vegetable oil. Animal or plant oil. Okay, plant oil. And the second raw material, caustic soda. Caustic soda, that we called as sodium hydroxide. Sodium hydroxide, the second name, the sodium hydroxide we called as caustic soda. Caustic soda, that's a powerful base. That's a powerful base. That's a powerful base. Caustic soda. Caustic soda, that's a powerful base. More pH value more than 30. More than 13. It is a very powerful, huge powerful base. More than 13 pH value. It's a powerful base. Okay, what do you think? Sodium hydroxide, that means caustic soda contact with our surface, skin, surface skin. It's burning, remember. Sodium hydroxide is highly base compound. Highly base means it is toxic and burning our, just like powerful acid. Powerful acids are powerful base, both toxic to our skin, burning our skin. Okay. Right. Hi. Okay, then what are the main raw materials? Any animal, Rehla. We can use any animal or plant oil. Oil, no? Fat or animal both. That's contain triglyceride. The material doesn't matter. For soap production, only need triglyceride. Triglyceride is a compound. Triglyceride contain any material, any plant or animal oil we can use for soap production. We can use for soap production. Har. Only first point I explained. What are the main raw materials for soap production? Sodium hydroxide, that means caustic soda, and triglyceride, animal or plant oil. Triglyceride and sodium hydroxide. Triglyceride and caustic soda. First point is done. First point is done. Now, is sodium hydroxide, that means caustic soda, and triglyceride reaction process we called as a special name. Special name. Actually, all chemical reactions, they have a specific name. They have a specific name. Okay, in soap production, very remember very well, the saponification is a name. The saponification is a soap production process chemical name. Chemical name. Actually, the sodium hydroxide, caustic soda, and triglyceride reaction process we called as a special name, that is the saponification reaction. Point 2. What's the point 1? In soap production, main raw materials, what are them? Caustic soda and triglyceride. This triglyceride and caustic soda reaction process we called as a special name. It is saponification. Saponification. That is saponification. Saponification. Okay, great. This second point. Okay. Now, the saponification means the soap is produced by a alkaline hydrolysis of fats and oil. That's actually saponification reaction. Triglyceride react with sodium hydroxide. It is produced glycerol and soap. You can understand another name. Another name. They are the raw materials, right? They are the raw materials. This is saponification. Saponification. Please make a short note. You have very limited time now. Less than 100 days to the exam. Therefore, don't keep anything at final days. Final days. Your short note writing and complete as much possible questions these days. Hi. Saponification. Saponification. Okay, this is saffron. Soap production chemical name, chemical reaction name. Okay, in saponification, what happened? Sodium hydroxide, that means caustic soda. Sodium hydroxide. Sodium hydroxide, caustic soda react with triglyceride. Triglyceride. Sodium hydroxide react with triglyceride. And it is produced soap. Soap, that is our product. Additionally, it is produced glycerol. Additionally, it is produced glycerol. Glycerol we call as a byproduct. That's one also product. It's a chemical reaction. It's a product, but it is not our main purpose product. It's a byproduct. Therefore, our purpose to produce soap. In soap production, additional product is producing, that we call as byproduct. Byproduct. Okay. In saponification reaction, they are the raw material. Please note down, raw material. This is the product. So, soap වලට අපි තව නමක් කියන sodium stearate එකක් දාගන්න. Sodium stearate. Sodium stearate. Sodium stearate means soap. Soap is a product. Then the glycerol is a byproduct. Glycerol is a byproduct. Byproduct. Okay, that is a summary of the saponification. Please note down on your paper, short note paper. Complete? Hurry. The most important part now. Okay, I'm going to explain the soap production process step by step now. Okay, please try to make a short note and attach to a note. Attach your note. Because I have given all steps in the note. But it will be more than that. මේවා පාඩම් කරනවට වඩා more than understand these things, these notes, more than understand this note, very easy to understand steps. Now I'm explaining steps. Okay, I'm explaining as a flow chart. Please try to understand. Try to get the 100% full idea. Then soap production is done. No need to worry. In soap production, what are the main raw material? Before that, I will give you this process is called as saponification, that already done. It's usually carried out under heating condition. Yes, heating condition. Okay, I will explain that later. Okay, the definition of soap. Soaps are the sodium salt of fatty acid. Sodium salt of fatty acid that we called as the sodium stearate. Sodium stearate that you can learn later. Sodium stearate. Sodium stearate. Sodium stearate means sodium salt of fatty acid that you can understand later. Which are long chain carboxylic acid. These compounds are commonly referred as soap and can be explained based on their chemical structure. Okay, that we can discuss later. The previous part we can discuss after production process. The main ingredient to produce soap, caustic soda and vegetable or whatever triglyceride compound. Okay, that we already done. In the production of soap, the ester bonds, that's very important. This part very, very important. This part very, very important. Okay, see, this part very, very important. Okay, you can note down on your short note. That is a saponification reaction with chemical names. Okay, I'm going to draw the chemical structure, chemical name. It is very, very simple. Okay, try to understand this, then you can understand biodiesel production also very simply. Okay, what is this? Do you remember biomolecule lesson? In biomolecule lesson, what is this structure? Tanya, what is this? Oh, I need answer now. Biomolecule, we did more than 1 month, I think. Dihini, what is this structure? Now don't remember. This is triglyceride. How to form triglyceride? Then even how to form triglyceride, glycerol and fatty acid. What is the structure of glycerol? CH2OH, CHOH, CHOH, CH2OH, right? This is glycerol. Glycerol connect with 3 fatty acid. What is the fatty acid structure? RCOOH. RCOOH. OH, sorry. RCOOH. COOH. Okay. Combine with 3 fatty acid, then what happened? Releasing H2O, producing ester bonds, between glycerol and fatty acid, producing 3 fatty acid, molecules removing. That we already discussed in biomolecule lesson. Amina, remember? This is glycerol. There are 3 fatty acids. 1 glycerol and 3 fatty acid produce triglyceride by 3 ester bonds. 3 ester bonds. H2O removing. H2O, H2O, H2O. 3 H2O molecules removing. Then only remain oxygen. Oxygen remain. Okay, that we called as a ester bond. This is a ester bond. This is a glycerol and 3 fatty acid. They are the ester bonds. But okay, remember, Matakai? Kabir? Good. Now it is a triglyceride with 3 ester bonds, right? 3 ester bonds. Now, what happened in saponification? In saponification, this triglyceride react with who? This triglyceride react with 3 sodium hydroxide. That mean 3 sodium hydroxide mean 3 caustic soda molecule. 3 caustic soda molecule. Okay, 3 sodium hydroxide. 3 sodium hydroxide mean the what we call the I forgot this word. What is this value? I forgot. I will remind and tell you. When we balancing, okay, it has a special name. I forgot. Uh, while balancing, this coming value is a 3. But in practically, when we doing triglyceride mix with caustic soda and mixing. Okay, that's a practical soap production. But in balancing, it's coming 3 as a value. Okay, that's a chemical reaction. They are the raw materials. They are the raw materials. Then it's producing soap. How sodium hydroxide and triglyceride, what they doing? What they have? What is happened? Break down these ester bonds. Ester bonds break down now. That we call as hydrolysis of triglyceride, right? In the hydrolysis process, for the products. Okay. Again, and 3 fatty acid. Matakai? Dihini? Just break down these 3 ester bonds, again produce glycerol and 3 fatty acid, right? Now, in the breakdowning process of this triglyceride, producing glycerol and 3 fatty acid. Glycerol and 3 fatty acid. What happened? This sodium hydroxide also break down as sodium ion and OH ions. These sodium ions combining with fatty acid. හරියට බලන්න. Sodium combining with fatty acid like this. Sodium like this. This is a sodium stearate. Sodium stearate is a soap. That's why we call soap is the sodium pinamacua. The soap is the sodium salt of fatty acid. Is a sodium salt of fatty acid. That sodium salt of fatty acid. This is soap. Sodium salt of fatty acid. Sodium salt with fatty acid. I got how to produce soap. Break down this triglyceride. 3 fatty acid combined with sodium. Then what happened to OH? 3 OH go to this side with CH2OH. Then it is produced CH2OH, CHOH, CH2OH that we called as glycerol. That we called as glycerol. ඉතුරු වෙන ටික glycerol හැදෙනවා. Is it lagging? Khabib? Lag වෙනවද? ඔව්. Now, three caustic soda. What now? Okay, no. Today morning, my Wi-Fi has a issue. I think now okay. Then how is it? Kabir? Okay. If there any issue came, please let me know as soon as possible. Hurry. Okay. This is the soap production. What happened in the saponification reactions? What's the meaning of saponification reaction? The reaction between uh, triglyceride and caustic soda. In the reaction of in the reaction, what happened? Triglyceride ester bonds break down. In the glycerol and fatty acid separate. This fatty acid combined atoms. Sodium atoms, the OH, three OH combined with remain CH groups. Then it is produced glycerol as byproduct and sodium state is a soap. So that's a sodium stearate. This sodium stearate. Sodium stearate. It has another name, sodium salt of fatty acid. The same thing, sodium salt of fatty acid. Oh, so soap here. That's the structure of soap. I think it's coming three because three sodium molecules, no? Three. And this is glycerol, this is a byproduct. Glycerol. Glycerol, this is a byproduct. Clearly note down this. This is a saponic chemical reaction. Chemical reaction. Clearly note down this. Saponification. Note down this. This yellow color line mean breakdown. Okay. Don't write that. Make yellow line the meaning breakdown in ester bonds. Then this produce fatty acid combined with sodium. Complete. Done? Complete? Amina? Okay. That is a saponification reaction. හරි. මෙතන දීලා තියෙනවා විස්තර. The description is given here. The production of soap, the ester bonds broken by the reaction between this triglyceride molecule and sodium hydroxide. What happened in the first step? Ester bonds break down. And the formation of sodium salt of fatty acid. That is a sodium stearate. Using sodium salt of fatty acid. Sodium salts of fatty acid, sodium stearate. And glycerol. Glycerol is a byproduct. Glycerol is a byproduct. The soap production reaction called as a saponification. Yes, soap production reaction called as a saponification. This is a chemical formation of saponification. Now I will give you full idea, step-by-step idea what happened in soap production. What will happen in soap production? First of all, I will explain step-by-step procedure of soap production. Okay, first of all, we have to get triglyceride. That means let's take coconut oil. The coconut oil is a type of triglyceride, right? That's a common type. We can use used coconut oil also possible. If you Sri Lankan condition, we can collect used coconut oil from else. No, we can collect. Then it is a waste management as well. No, it's a triglyceride. Therefore, we can use used one also. We can use already used coconut oil, possible to use. Okay, actually, the chemical reaction production process doing in a chemical reaction chamber in last week. And I think on this purpose, only for understand, I think the reaction doing in a beaker. Okay, now I'm going to prepare this soap sample in this beaker. Okay, this beaker. Okay, first step, I want to add triglyceride. This is a triglyceride. That means coconut oil. Coconut oil, whatever type of oil we can use. As example, think we got coconut oil. If you want, you can make a sample soap in your home. Very easy. You need 100 gram of caustic soda. You can ask from hardware selling caustic soda. Then you can prepare soap. You have to be careful a little bit. I will explain. Safety first, because that's a chemical reaction. Therefore, we have to be careful. The chemical reactions, actually, it is exothermic chemical reaction. Therefore, we need to make safe. Okay, this is a chemical. Okay, easy understand. A beaker, actually it is not a beaker. Special reaction chamber we have to use for saponic reaction. For easy understand, I think I'm doing this reaction inside this beaker. Okay. Okay, now this is a triglyceride. I got the triglyceride first, triglyceride. Then using heating pan or whatever heating method of the chemical reaction chamber, we can heat this. Heat this. Okay, heat in normally 90 Celsius up to 90 Celsius, 90 to 120 Celsius, we can heat this coconut oil. Okay, heating, heating. Okay, when it is heated, caustic soda. Do you have seen caustic soda? Salt. Caustic soda can it's white crystals, white color crystals. Okay, we can get another beaker, another container, make 50% solution. 50% solution means if we add sodium hydroxide, caustic soda 500 gram, add water 500 milliliter. That 50% sodium hydroxide solution that we call as aqueous solution, right? Aqueous means dissolved in water. Really understand? Aqueous solution, 50% sodium hydroxide solution. Sodium hydroxide solution. When this triglyceride is heated well, gradually adding this 50% sodium. 50% sodium hydroxide means 50% water, remain 50%. Understood? 50% sodium hydroxide add into this container reaction chamber, and in this mixing time the stirring is must. Stirring, that means tightly mixing this solution, otherwise it is ununiform reacting. Due to ununiform reacting and ununiform heat management, that can be ununiform product. If we need uniform production process, the stirring, therefore actually in reaction, they have special mechanism for mixing. They have special motors and mixing. If you using in home condition, container you have to mix this way. Okay, that's the most important part. You must mix it. Why we need to mix? The first thing, for heat management, because it is heated, therefore you have to maintain the heat. Maintain the heat means entire reaction same temperature, otherwise heat damaging. It's if final product, your final product. Okay, therefore you have to mix it well. Mix it. Okay, when you're mixing, after some time you can, when you're mixing well, after some time you can feel some thickness, increase the thickness of this solution. This is the end of saponification reaction. That means already produced soap now. That's saponification reaction. Okay, that's the end of saponification reaction. Okay, after saponification, after this reaction, tell me what's produced in this, what's remain after saponification. After saponification, what do you think? What remain? Monad make hadin, monad make tien. Now it has a solution. Okay, tell me one by one. What's available after saponification reaction? Kabir, what's මොනවද මේක තියෙන ඇත්තේ? Quickly. Initially, before saponification reaction, before saponification reaction කියන්නේ what's contained the saponification? You can start the reaction. It contains sodium hydroxide, right? Clearly තේරුම් ගන්න. It's contained what else? Triglyceride. And we add 50% water and water up තියෙනවා. Okay, that's before saponification. Tanya, send me what producing after මොනවද මේක තියෙන්නේ after saponification. Now saponification reaction done. Then what are the producing? Quickly. Fatima? Quickly. Very good. Glycerin is producing. Very good. Glycerol is producing. Glycerol. That's as byproduct. Glycerol is producing. What? Nothing. Soap is producing. Good. Soap is producing. What else? Is that all? Kabir, it's only produce soap and glycerol. Are you sure? Dihini, any idea? Quickly. Samya? Tanya, what else? What happened to water? What happened to water? Water also there. And water is not reacting. What do you mean? It's contain water. 50% water there. Do you think all sodium hydroxide reacting? All sodium hydroxide reacting every time? No. Unreacted sodium hydroxide also there. Unreacted sodium hydroxide. Unreacted sodium hydroxide. Is that all? Yeah, that's all. Okay, now then what we then මොකද අපි කරන්නේ? Now saponification, the soap production is completed. So production is completed after mixing 15 minutes, approximate 15 to 17 minutes. We can feel some thickness of this solution. That means the saponification reaction is done. It's producing soap, glycerol, and it's contain unreacted sodium hydroxide and water. Okay, what is your next is actually next step is separate this soap and glycerol, because soap is the product, byproduct. No, 50% වගේ හැදෙනවා. Soap and glycerol. Okay, therefore I am going to glycerol now. Okay, what do you think? How to separate that? Okay, very carefully understand this part. That after this saponification, we have to add sodium chloride here. Sodium chloride, right? Sodium mixing. For what? Increase the thickness of this glycerol. Sodium chloride dissolved in soap. It dissolved in glycerol layer. Then what happened? It's increased the density of the glycerol. normally දැන් මෙහෙම නිකන් තියෙද්දිත් glycerol density is greater than soap. Normally soap is floating on the glycerol, but when we add sodium chloride, what happened? Increase the thickness of this aqueous layer. Increase the thickness more increase the thickness of this glycerol. Okay, in the next step we can centrifugate. The centrifugate is the next step. Centrifugate. What's the meaning of centrifugate? After adding sodium chloride, we can centrifugate. What's the meaning of centrifugate? Centrifugate. Very important. Okay, what's the meaning of centrifugate? Centrifugate means using a container rotating like this. In the rotation, what happened? High density particle. High density particle means now dense glycerol particle. Glycerol going down and soap particle in now. In the saponification, in the centrifugation process, we can separate. That's a not like that. The centrifugator, just like a funnel. Okay, what happened when we add this solution into this centrifugator? It's rotating. Due to rotating, what happened? High density particles go down and low density layer, soap layer, comes as a top layer. This is a top layer. Now dense glycerol is there. Glycerol is there. I got up to now. Okay, please send me. Send me. Up to now in doubt. Dehini, Fatima Kabir, Ramya. Up to now. Okay. Centrifugation means Rehlan. Just add into a container. Then make it a kilitanda. Now just add into a container and it is rotating with high RPA. මේ වගේ container එකකට දාලා ඒක rotate කරනවා just. That's centrifugation. In the centrifugation, what happened? This high density glycerol particle and low density soap going up. Then we can see clearly this separate due to density difference. Okay, Rena? Yes. Now this is a soap layer. Make especially they have pump. Now this soap layer pump into another container. Okay, now this is a purified soap, separated soap. That's only soap, no glycerol. It has some impurities, but just soap without glycerol. Okay, what we doing to the remain glycerol again add sodium chloride. May remain glycerol water again adding sodium chloride. The same thing. Okay, again adding after pumping this that we call as soap pumping. Soap pumping. Pump. Soap pump in soap layer pump into another container. Now again for this remain glycerol, again adding sodium chloride. Sodium chloride, salt. Again centrifugate. Again centrifugate. In the second centrifugation, if there are any remains of amount, we can separate. We can separate. In the second centrifugation product also pump into this. Now we can remove this glycerol amount. Cosmetic production, we can use this. Can remove for cosmetic production and toothpaste productions. Okay, that one also product, but in soap production, that we call as byproducts. Hari. Now that's a separated soap. Separated soap. Now, what you think? This separated soap is are they pure? Can we use? Is this like this? No. If we separated from glycerol, it's contained water. Still it's contained water. Still it's contained glycerol is done. Glycerol is done. And unreacted sodium chloride is highly toxic. Because I told unreacted sodium chloride, it is highly toxic to our skin. It's highly toxic to our skin. Unreacted sodium chloride. Then what we can do? Then how we can remove sodium chloride? I told sodium chloride is highly base compound. Therefore, to remove unreacted, we have to neutralize process. Neutralizing process means we have acid. Normally we add citric. Citric acid means contain acid. Its chemical version add to neutralizing process. Neutralizing process. Are you clear? Now 90% of production completed. Hari, Fatima? The unreacted sodium chloride toxic to our skin. That's why you can prepare a soap in your home, but you can't use them. Okay, you can't use because you can't neutralize. No, if you not neutralize, it is very toxic to our skin because unreacted sodium chloride is limited. Well, it is not a very dangerous thing, but don't use them. Washing purpose skin it is toxic. Reacted sodium chloride, highly base condition. Good. Pehla. Okay. What we doing? We can add this separated soap. Then we can remove unreacted sodium chloride. Remove. Not actually removing, neutralizing. Reacted sodium chloride neutralizing. After that, water and soap only. Now it is safe, no? Now we can use. Okay, after that, slide the heat in that. For evaporate this water, additional water amount. Okay, water also removing by evaporating by heating. Okay, after removing this water, we can feel some increase of thickness. Increase of thickness. What I mean, we can see some increase the thickness of this soap. Thickness, the density is increasing. Density increasing. Now, when increase the density, we have to filling materials. Filling materials. Sodium chloride removing by neutralizing. Neutralize by citric acid. Citric acid. Neutralizing by citric acid. Water removing by evaporating, right? Heating. Heating. Hari. No note karganda. Tut also given, but easy to make a short note. Okay, after heating, now increase the thickness. Gradually thickness increasing, the density of the soap is increasing. Now what happened? Now we have to introduce filling agent. Why we need to add filling agents? Because it is a very thick solution, it's still very thick solution. We can't use as a solution, so in solid. And I want to increase the quantity. Otherwise, pure soap විතරක් හැදුවොත්, if we make only pure soap, one soap cube, the price will be more than 1,000 without filling materials. Okay, there are filling materials. In the next step, we have to add filling material. Okay, that's the most important, most interesting thing. Do you think what are the filling commonly used filling materials? මොනවද done? But we commonly use filling material in soap production. Filling material increase the quantity. Anyone? Tanya? Dihini? Anyone, do you have an idea what are the filling materials? Which type compound we can use? Can we use which type? Any idea? If you observe Vim කැට තියෙන්නේ. If you observe clearly Vim, you can see some filling material. What do you think? What are the main filling material? Pehlan, any idea? මොනවද දානවා ඇත්තේ? That's filling material. Filling materials means just increase the quantity. Now think pure soap produce only 200 gram, but I want 500 gram. Then I want to add filling material. Okay, in Sri Lanka, not on Sri Lanka, in soap production, mostly used filling material is sand. Can you believe? Sand, valley tamadan, silica sand. Silica sand, the sand grinding into small compounds and adding into particular soap. Normally, if you got very soft soap, like baby soaps, for baby soaps, texture of soil is very low. That means like a powder. We have to grind into like powder to produce soft soap. But Vim වල දැකලා තියෙනවද වැලි වගේ තියෙනවා? Do you have feel? Yes. Contain like sand part, right? Normally rough soap, washing soaps, these sand particles we can observe because they are rough soap. We're not grinding well. They are less expensive. They are not expensive. Soaps normally expensive. They add sand in powder form, grinding into powder shape. Powder shape. Okay. Add filling materials. Normally, as filling materials, we can use sand and sodium carbonate. Sodium carbonate also we can uh, grind and we can add. Hurry. Sand means silica, right? Silica. The name silica. Sand is sand. Okay. Hurry. After filling material, the quantity. After increasing the quantity, very simple. We can add different colors and fragrances, smell agents, and different extractions. Normally, cohomber, comarika, different types extractions, chemicals adding with these smells and colors. Then finally fill into molds. Molds mean the shape. Then finally in the cooling process we can get after cooling process we can get solid soaps. After that, labeling, packing and come to the market. Are you good? Any doubt in this production process, please ask now before go to the tute. If you have any doubt during production process, any step doubt, you can ask now. Okay. If you got this entire story, any question you can answer without read any tube. You can try today. Lot of past papers or production questions you can try. Any doubt, Fatima, Kabir, Dihini? Quickly. Yes or no? A good question, Tanya. Why are we adding sodium chloride in the first beaker? Not first beaker, Puta. After saponification. After saponification. After saponification, normally glycerol is high density, soap low density. It's naturally separating. But our requirement increase the separation quality. That means easily separation. For this easily separation, we can increase the thickness of the glycerol. No, we can increase more thickness of the glycerol. Glycerol thickness density it's easily separating. I got adding sodium chloride. Called as salty. Adding sodium chloride. Then what happens? Sodium chloride dissolving these excess solutions, glycerol, then increase density of glycerol. In the centrifugation process, we can easily separate, easily go down this all glycerol particles, go down, dissolve sodium chloride with sodium chloride. Understood? In the second step also we adding sodium chloride if there are any remain soap particle, separation purpose. Harneet. හරි. Let's go to the tube. දැන් ඔය ටිකම තමයි තියෙන්නේ. The same thing is given. If we read, the lesson is done. Production process, the basic principle. Soap is manufactured by sap that you already know. Okay, that's the basic saponification reaction again given. The nature of the reaction system, oil and aqueous sodium hydroxide. Aqueous sodium hydroxide means dissolved in water. Aqueous sodium hydroxide are immersible. Immersible mean not dissolving, water polar, non-polar and polar solids not dissolving, not mixing. Therefore, that's why therefore two layers are formed, oil layer and aqueous layer. The reaction occur two layers. That's why the mixing is required. It's two layers, polar solution and non-polar solution. That's why mixing is required. Efficient mixing is essential because reactants between two immiscible places. If it is mixing, no need excessive mixing. It's two layers. No? If we not mix, not reactants are collision reactant molecule. To collide this reactant molecule, we have to quickly solution. In the product formation, the main product is a soap, and as byproduct it is producing glycerol. In the separation process, after the reaction, soap from the aqueous glycerol is recovered by after glycerol is separating. The crude soap contains. Crude soap means impure soap. After saponification, that we called as crude soap. Crude soap can crude oil can same thing. Crude oil means impure oil. Same as crude soap means impure soap. After saponification, it produces crude soap. Not clear, not clean. It contains glycerine, it contains unreacted oil, it can contain unreacted sodium hydroxide. That important. Sodium hydroxide is harmful skin. Must be neutralized before use. Must be neutralized. Next, salting out. Adding sodium chloride to the aqueous layer, then decreases solubility soap in water and enhance the thickness of glycerol aqueous solution, and separation is accelerated. Density based separation. Salt increase the density of aqueous layer. Very important. Salt increase aqueous layer. In the centrifugation process, soaps come to top because low density aqueous solution, glycerol and sodium chloride going down. Then the separation is easy. Okay, the remaining water amount, we can 30% of water. After separation, it contains 30% of water. Normally, in the separation process, glycerol of water can be removed. After separation, it contains 30% of water. Therefore, we can heat up to 70%. So 70 Celsius and evaporate. Okay, removal of remaining glycerol. Wet soap is treated again with salt solution. I told you after soap separation, then we can add salt into the glycerol. This remain glycerol amount. Again centrifugation. Finally, soap has reduced glycerol content. Finally, the remaining part also we can separate. Addition of filling agents. They are the filling agents. Increase the bulk of the soap, that means quantity, reduce production cost, improve texture, and the quality of the soap is maintained by filling agents. Filling agents. Example: sodium carbonate, sands, and talc is normally in Sri Lanka not using talc. Sodium carbonate and sand we can use in Sri Lankan. Finally, adding coloring and fragrances. Okay. And finally, drying and packing. Okay. That's all soap production. Okay. Now, do you have any doubt? The same thing explained in the tube. Now, any doubt? What do you think? Can you answer any question now? What's the purpose of, there was a MCQ question. What's the purpose of adding citric acid to the soap? Separated soap. What's the answer? There was an exam question. What is the purpose of adding citric acid to the separated soap? What's the answer? MCQ question. What's the purpose of adding citric acid to the separated soap? Separated means glycerol removed soap. Dihini? No, your answer should be complete. Neutralize unreacted sodium hydroxide. Neutralize unreacted caustic soda. Hurry. You can search more questions related to soap production and complete today. Okay. Mixing of oil, fat, and sodium chloride. They are the steps. Saponification reaction, formation, that's the end of separation, layer separation by centrifugation, salting out, salting out means adding salt, okay. Removal of impurities, heating and pumping, final purification, adding filling agents, coloring and agents, and drying and finalizing. Other side also given a flow chart, same thing. Okay, final topic. Okay, before moving to uh, liquid soap production, do you have any type of doubt about soap production? Quickly, I'll give you 2 minutes. Please go through again production process. If you have any type of doubt, please send chart එකක් ගහගන්න. Make a short note. Complete. Amina done. Okay. 5 liquid soap production. Okay, liquid soap production. The same process. It is soap. Soap, like soaps, these substances have hydrophilic head as well as hydrophobic tail. That one I will explain later. Okay, the may skip part. Okay, the main difference is in normal soap production, it is sodium salt of, but liquid soap production, it contains sulfur and sulfonate group in the chemical structure. We need to add sulfonate compound as well. That's why it's make as a liquid. Okay, they are the sulfur related compound. Sodium lauride sulfate, actually if we add the sodium lauride sulfate, it is not environment healthy, but it is hard water. Do you know what is the meaning of hard? Magnesium, calcium type, iron rich water. Liquid soaps not dissolve in hard water, but if you use sodium lauride sulfate, it's no any problem, but it is not environment healthy. But it's healthy mean it's environmental pollution and no. But there is another chemical, chloride, benzene sulfide, sodium lauride, benzene sulfide. It is environment healthy and biodegradable. Right? The sulfur compounds. හරි මෙතන තියෙනවා අර මම understand and read and understand same thing, the laboratory soap production, soap sample production, that you can read the same thing. I will give you the final process, the washing process. Hari, if you soap molecule, it's just like this. Okay, Mabala, that's the most important. Okay, this is a soap, right? Sodium. This is washing process. Final topic. Washing process. Okay, this is actually shape of the soap. It's contain sodium, oxygen, and R carbon chain. R carbon chain is a long R carbon chain that we call hydrocarbon chain. It's just like this. Okay, this is a soap molecule. What is this? R carbon chain. Therefore, this soap molecule contains soap එක molecule එකක් ගත්තාම it's contain, that means sodium stearate molecule that contain head and tail. Sodium include this part we call that tail. This is the head, and this is the tail. Okay, this is the head and this is the tail, and that's why I skip this part to explain finally. Maybe this is a head, sodium include head, that we call as hydrophilic head. Hydrophilic means it's water dissolving. Water dissolving. Polar head. It is a polar end. Hydrophilic. 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 Hydrophilic means it is polar. Polar means water dissolving. Water dissolving. Hydrophobic. The tail is hydrophobic. See, tail is hydrophobic. Hydrophobic. Tail is hydrophobic and it is non-polar. Non-polar means it is not water dissolving. Not water dissolved. Not water dissolved. But mean the advantage of this non-polar side hydrophobic tail dissolving oil particles. Dust dissolving particles dissolve in this tail. That's why when we apply whatever container අපි ගමු මොකක් හරි භාජනයක oil stain එකක් oil පැල්ලමක් it's contain oil stain. Wash this? No, oil not dissolved, therefore it's not removing. But when we apply soap, what happened? The soap contain hydrophobic tail. Hydrophobic tail is non, therefore non-polar this make a dissolve in oil particle. Oil particles, lipid particles dissolve in this non-polar tail. And hydrophilic head is water dissolved. Then entire soap is water dissolving. Then what happened? We wash out this entire molecule. I got this washing process. I got. That's why the soap doing a multiple type of washing purpose, because one part of this soap molecule polar, the other side, tail side is non-polar. I got hydrophilic head and hydrophobic tail. Understood? Yes or no? Do I need to explain again? Dihini? Clear? Fatima, Kabir? Rihlan? Clear? Okay, that's it. Soap is done. Okay, what's your homework? Please find all past paper question related soap production and complete. Then අපි class එකේ කරනකම් ඉන්න එපා. You have to work yourself. As maximum I will discuss all questions, past paper question, but 100% we can't cover within our limited period. You have to work yourself. Now after I explain soap production, you can complete all soap production related past paper questions. That's a method. After next day I complete biodiesel production, you can complete all biodiesel production related questions. Lot of questions there. Essay questions based on soap production. Okay. End of soap production. If you have any type of doubt, you can ask the washing process. The head water soluble. Head water soluble. The tail hydrophobic. Lipid soluble. Lipid means non-polar thing soluble. Lipid soluble. Complete. Complete. Amina. Okay, that's the end of soap production. Soap production completed. Okay, remember the homework. Adama karanda today, start today. Find all production related past paper questions and complete. Okay, that's the end of soap production. Let's complete next day biodiesel and paint production. Within 2 weeks, we can complete the lesson. Again, you have class after tomorrow, Friday. Friday, let's try to complete biodiesel. Then next week we can complete the lesson next Wednesday. Okay, goodbye.